Okay, powering a Raspberry Pi Zero from a UKMARSBot was what I've called this. And I guess probably the first question to ask is why bother running a Raspberry Pi to a UKMARSBot? And there are a couple of reasons I had for this. One is to allow supervisory software or software in general to be written in Python, which is often the preferred language of schools and other educational groups. The Pi Zero W comes with good networking, it's Bluetooth and it's Wi-Fi stuff. Cheap camera available, can be connected, so can start looking at some video or image capabilities on there. And I'd still leave the Arduino do the nitty-gritty stuff in terms of looking after the motors and the sensors and so on. So that was kind of what was in my mind behind the Raspberry Pi. But of course, we didn't really need to reinvent the wheel on that because Rob, although he's not here, get the credit now for what he's been doing. He's already started up a project on interfacing the Pi Zero rather than the Pi Zero W to UKMARSBot, and there is a good load of material available to you there on the GitHub reference I'm just giving you up on the screen. The stuff that Rob was working on was working with Peter, so actually using the Arduino control software on the UKMARSBot, and then a serial communication between the Pi and the Arduino controlling the UKMARSBot. He's also put up some 3D files for mounting hardware, which is kind of useful. And fortunately, I was able to persuade David to print some of those files off for me, although I don't have a 3D printer. But I'm just struggling here. So I did manage to get them pulled off Rob's files. And the other thing that Rob does do a little bit of that is talking about the power requirements for the Pi Zero 1.3, looking at the size of the regulator that's on board with the Nano, and the kind of power requirements that you have for the Pi, and seeing whether that might happen. And Rob, it's worth having a read of Rob's stuff just to see the kind of approach he took to turning stuff off on the Pi Zero so that the power requirements would come down. The thing to note really is that Pi Zero W is much hungrier than the standard Pi Zero, and whichever way you look at it, you're not going to power it through the onboard regulator of the Nano. You're just going to run out of steam. And I'll kind of give some information around that. The thing to note about the Pi Zero W is it's pretty volatile and spiky in its current demand. If you watch it on your power supply on the bench, it's flipping up and down all over the place. Just a second, I've got to let someone in. So it's a pretty volatile and spiky demand, and actually it's really volatile and spiky when it's booting, markedly so from when it's in its normal running state. The Pi Foundations say get yourself a 5-volt 1.2 amp supply for the Zero W, and they say bare board is about 150 milliamps. When I looked at it with a camera attached and the radios on, it was averaging about 180 milliamps in its normal state. So it's reasonably power hungry. And if you do something like that, which is to watch a video playing on the Pi Zero on VLC using VNC as the connection, then you go up to about 300 milliamps as an average consumption while it's doing that stuff. So the current requirements are pretty high and significantly higher than for the Zero 1.3. And again, clearly too much for the Nano. You might get 800 milliamps out of the Nano regulator, but we'll come on to that in a moment. So I looked at prototyping something to see what kind of power supply would work, and threw some stuff together on a breadboard using a standard 7805 with 100 microfarads of smoothing. And that just goes around a constant boot sequence loop because it basically drops the voltage at some point critically and the whole Pi gives up and starts again. So wasn't particularly enamored with that. Tried to up the capacitance to try and smooth some of that out. And that was pretty unreliable, usually failed. Every now and then you might get a boot that goes through. And then once it's booted, actually, things seem to be okay. So it seems to be the boot that's really sensitive, but that wasn't helpful. And then finally, in desperation, I tried paralleling two 7805s, and that actually works. So you could parallel two 7805s, but not ideal. And given the kind of current demand that's going on here, the losses on the heat you're going to generate in those regulators is going to be a little bit of a concern. So I tried a different device, which is the Oki 78SR 1.5, and that with just a simple 100 microfarads smoothing boots fine and works fine on the breadboard. So I'll just tell you a bit more about that. It's a Murata device. It'll take an input between 7. Its nominal input voltage is 12, but you can go down to 7 with it, and you can go up to 36. It's short circuit protected, and they claim 89% efficiency at 7 volts. So a lot less need for heat sinks and all that nonsense by using that device. I'm just going to let somebody else in. Oh, Rob. Hi, Rob. Hi. So we're just going through the Pi 0W powering. So that's the device I tried. And the other thing that's kind of handy about it is it's pin compatible with the 7805. So you can actually put this in anywhere that you put a 7805 in. But it's a little bit more pricey than a 7805. I think I paid about £3.20 for one of these. But I guess most people have found this now that supply chains are not very good at the moment, and some of the components are getting expensive or aren't available. So you might have a bit more trouble finding one right now. So I kind of figured out then that I needed to get, I wanted to use that device as my regulator because I think it could provide enough current. And then I want to set myself some requirements for what I was trying to achieve to get this Pi 0 W mounted on top of the UKMARSBOT. And so I basically set myself a task of building an ancillary board which gives the power supply. While it was there, it could do the take the serial lines and flip the pins around as necessary between the Pi and the Nano, level shifting the 5 to 3.3 on the transmit line, and also including the diode to allow the programming of the Arduino to carry on. I wanted the supply to be switched with the existing switch on the robot, so when you switch the robot on, the robot turned on, and then when you turned it off, it was turned off, and you didn't have to fiddle around with separate supply switching. Still wanted to get to all GPIO and all the peripherals on the 0W, and still wanted to let the Arduino be looking after the motion and the sensors. And I saw no reason why we shouldn't polarity protect the Pi while we're at it. So that's what I kind of set out to do. And this is the schematic of what I did. Can everyone see that? Is that clear enough on your screens? So on the right-hand side is basically stuff coming off the Nano, off the UKMARSBOT, and on the left-hand side is the feed onto the Pi 0. There's the regulator device in there. with its smoothing capacitor, a level shifting resistors, and a shop key put on the Nano receive line so that the programming would still work. I think that's the same shop key that you used as well, Rob. Actually, just happened to be the one I found in my box. So that's the schematic of the board, and this is the variable that I made up from that schematic, and the Pi 0W. Can you see my mouse moving around here in the bottom left-hand corner? No, you can't, because I've done that now. Here, these are the GPIO pins that you use. There's a couple of 5-volt pins, then there's ground, and then there's the 2 serial lines clustered together. So they're the ones that are taking off from this connector over here, and this is the stuff coming in from the Nano. But obviously you need to bring in battery volts or VM, the motor voltage, off the motherboard, so you can actually regulate it down to 5 volts using this regulator. So you need not only the 4 pins that are presented for the serial on the UKMARSBOT, you also need to somehow get hold of VM, and then you can ship them across to the Pi 0 over here. One happy coincidence is that layout of pins is exactly the same layout of pins that a standard Bluetooth module uses. So you can actually unplug the Pi 0 and plug in a Bluetooth module and just use the thing as a straightforward Bluetooth device. Just pausing again to let somebody else in. Oh. Hi again, Rob. So that's the strip board. It's basically half the width of a Pi 0 board, so you can put it on one side of the Pi 0 board over the USB and power ports and things like that, leaving the GPIO pins vacant, and the 2 extra breaks that are shown here are actually mounting holes to put the board up onto the above the Pi 0W. So the only other thing was how do you get voltage up to the board? So I built a small Caddy board, which is here, to carry the polarity protect diode. Got right angle header here, spaced out right to pick up the pads for the diode that are on the board. And then it takes off here, just at the bottom of that board is a 4-pin takeoff of the power supply. And on the left-hand side, you can just see it tucked in. I hope you can see it now. I'll show you another picture of it. So it sits in right tight against the header for the Nano and between the motors, and presents up 4 pins, all of which have got essentially VM on them. A bit more close up. It is quite tight, but it all fits in there. You can see it's all nesting down in between the motors there and the Arduino board. I put 4 pins on it just for mechanical reliability of the connection. I didn't want to be having wires pulling off on a single connector. And then I used some of Rob's mounting hardware. Thank you, Rob. Which David printed for me. So on the left-hand side, you can see the motor mounts from Rob, which are basically have a mass on top of them, so you can actually screw down into them. And the power Caddy board is there just by the Arduino. And then on top of those motor mounts goes the carrier for the Pi 0W. And instead of leaving those as screws, I actually turn those into studs, so I could drop the board on top and a nut on top of that and locate it on the studs. Also coming in, you can see just by the side of the Arduino on the right-hand side there are the serial lines which will merge through. This is the mock-up build before anything was committed. You can see this is starting to look a little bit like a battleship, so I think I can probably call it Dreadnought. Just to make sure that everything would stack on top of each other and still allow room for everything to happen. And you can still get to all the GPIO over here, and you can still get to all the other ports on the board under there. And that was pretty much it. That's the built version of the board. Taking putting a camera on front of it, thanks to Lego, and that does actually power up and seems to run, has a reasonable lifetime as well. I guess worth saying, what would I do differently? I think consider changing the rectifier, the polarity protect diode anyway. It drops about a volt, I think, typically, and we could get away with something probably dropping more like half a volt there. And it's also very large, so the Caddy actually helps that problem because it takes the large component. And I either use better quality strip board, because the one I used was very thin and horrible, or make a PCB up for it. But it does get around the fact that it's got a very spiky need for power coming off the Pi Zero. And I think that's it. Anybody?
Okay.
Any questions?
Do you use the same battery, or do you power it from a different battery?
Using the same battery, yeah. So,
yeah. So how long does it last with the Power Zero running?
I don't know. I haven't done that definitive experiment because I value my SD card a bit more than that. I've certainly left things running for sort of 20 minutes, half an hour.
That's fine, isn't it? I mean,
yeah.
To run with.
Obviously, I haven't been using the motors at the same time, so that would stick it down. But with that kind of amount of time, I'm just looking for what batteries I've got here. I mean, the batteries I'm using are rechargeable 9 volt, allegedly. They deliver about, by the time they've gone through polarity protect, they deliver about 7.5 volts. They say they're 650 milliamp hour. So I guess it should be good for half an hour.
I wonder if the dropouts that you see are as much because the input voltage to the regulator is sagging, because things have a dropout of around about 7 volts anyway.
Yeah, well, I have seen no problems at all using this switched regulator. It's worked absolutely fine and faultlessly, and I'm going to regret saying that probably. But the 7805s, I'm not quite sure what was going on there, because literally doubling them up was absolutely fine then.
They've got quite a hard current limit in them, and if your peak current was more than 1.5 amps, and it could have been, that would instantly drop out.
And it's difficult to provide a low enough input impedance on those, because those are gigahertz parts. You're in the gigahertz range with those Pis. So I used a switching regulator on when I adapted Ken's stepper. Put a Pi Zero W on that. I switched the regulator out for a switching regulator, and I didn't have any problems either with the switching regulators. I seem to be much more tolerant to these very sharp peaks.
Yeah. I was taken by surprise. I really, they're clearly quite short spikes as well, I think, Rob, because they're very hard to see or measure.
Well, it's RF domain, isn't it? I mean, it's 700 meg, right?
Yeah.
You might have cured the problem, actually, if you'd have put something like a ceramic capacitor across your 100 microfarad, because the 100 microfarad electrolytics have got quite a high series resistance, especially at those kind of frequencies.
Yeah.
And your switching regulator will have filtering that works at those kind of frequencies.
Yeah.
We were when we were dealing with those sort of hundreds of meg, we were using sort of high-end scopes to try to track down power problems. And sometimes, I mean, especially for a hobbyist design, it's better to just swap out a part and swap in something you think's gonna, is dealing with those. It's been designed to deal with those sort of high frequencies.
Yeah.
It's tricky doing it as a hobbyist because you usually don't have the equipment to actually diagnose. If you want an X7R or whatever it is, tuning the different type of capacitance for that, that impedance, that reactance at that particular frequency. You've probably done good, but I always find as a hobbyist it's tricky. If you've got something that works, it's great, but as soon as it doesn't, it's a pain.
Yeah.
I've had quite a bit of experience with the Raspberry Pis and the Pi Zeros and the Zero Ws that we've used at school, and with all of them, as soon as your battery voltage drops a bit, they just won't boot up. It's that boot up process that really canes them.
Yeah.
I mean, I've actually been at school for about 7 hours today trying to get a Raspberry Pi 4 thing ready for Pi Wars. We've destroyed 2 Raspberry Pi 4s and a couple of other bits.
Yeah. Raspberry Pis are famous for, requiring the right sort of USB adapter for them to work, so they must be very finicky on the power supply.
Yeah. Raspberry Pi 4s are even worse.
Yeah.
But they're serious things.
Do you think your 9-volt rechargeable battery could be having problems with the current spikes?
Well, I guess the evidence is no, because if you give it the right regulation on there, it works fine. But as soon as I put the switching regulator on, then it worked fine. I was just a bit bemused when I was dealing with it. I mean, I only use the 78 dies because they're there, right? They're in the toolbox, so I'll have a look and have a go. And it was really just an idle speculation to put 2 in parallel, and they work as well. It's just it's true. The Zero W is definitely far more power hungry than the Pi Zero on its own, especially with stuff taken out. I would like to think.
Do you know what type of battery you've got? Because there are 2 of those. One of them is a 2-cell, just a straight lithium battery with a recharger in it, and the other type is a single cell with a boost converter already in it.
Well, I haven't taken them apart. My guess is that they are actually single cell with a booster in it.
Right, even though they only run at sort of 8 volts. Because generally, the problem with the boost converter one is you tend to get 9 volts until it goes flat, and then it just switches off with no.
Okay.
No thing, but it can be pulled down if the boost converter is not very good.
I mean, if I'm lucky. I don't know, Derek. I mean, when one fails, I might have a look inside.
But with this converter, it works.
Yeah,
as Rob said, that's the important thing.
I mean, I'm running, just as a comparison, I'm running a non-W Pi Zero, just a stock Pi Zero with a nickel metal hydride battery, using the 5-volt regulator on the back of a clone Arduino Nano. So I think that's a 1117 or something on the back of those. It's a linear reg. What was that? Sorry.
Has that got about an amp capability?
Well, I mean, if you had a good ground plane, you would, but none of them have. Right. So I would doubt very much whether you can pull 700 milliamps out of it. Right. But that's a linear reg running on nickel metal hydride. But I wouldn't at all. I mean, I did the calculations very rough on the. You can see them on the on my GitHub account. for the general current, but I think I'm pushing it, you know. But I haven't had instability problems, right? So whether it's a nickel metal hydride that helps, or the just the lower peak current of the Pi Zero.
Yeah. Yeah. Anyway, so that was it. It was quite useful to get to. I quite like the power caddy, getting the power out from the switch supply on the robot. That was there's just enough room for that, and that actually works pretty well. So you don't have to have stuff stuck on the back of your battery or anything like that. You can just pick it up there. But there you are. My first foray with Pis, and found out they were very power hungry.
Yeah, it looks good.
A silly question. On the front, where you had the camera mounted, there was a Lego strip, and I noticed that at least the visible hole neatly fit between the posts of the Lego strip. Does the other one? Is it actually the same spacing?
Of course not.
Okay. I was just looking for a happy coincidence.
It's close. I'm just going to see. Yeah, you see, I've actually drilled through. I'll just pull that photo up just a moment. So I'll just go back one here.
No, that was it. You were on it there.
So the one you can see here, which is sharing the mounting with the mounting of the sensor board, right? So I've just literally pillared up the sensor board, although I am using 3 mil rather than 2.5 mil. And on the other side, it's nearly good. So actually, there's an oversized hole in there, just to allow you to fudge that into the full. So unfortunately, it's not quite.
Right. I was just wondering about the happy possibility of putting Lego parts on it, as if we haven't found enough ways to mess with the poor thing already.
Well, I think there might be some mileage in that. I think, and certainly once you get off, you only need virtually one bit, don't you, that's anchored to the board, and once you're onto the Lego pitch, you're away. So I don't think that's impossible. I did use Lego, as you can see, because it gave me the vertical mount for the camera as well. And then I just drilled through the Lego to take that. Okay, we're on to show and tell, really. It's stuff that you guys have been working on, you might want to talk about. Does anybody want to take the floor?
Okay, yeah, I've got a little demo I can possibly do, if it works. So I'll start with that, and then I'll explain what it is. I have to go onto the dodgy cam. Will the dodgy cam work? Oh, there we go. Oh, very dodgy because I can hardly see what it's doing. Okay, so I've been working on this. I'll just somehow let's go down like that. Just show it doing something. Yeah, that's right. That's enough of that. What that is a that's what it does at the moment. That is a PIC 1 or PIC 1.2 V1. So this is one of our really early PIC 1 replacements from, I think it was 2015 or something, running Pete's Maze Runner software. So hopefully by the time it's going, it'll be able to do a maze maybe. But it's running Pete's software. Or
can we see that demonstration again?
Yeah.
Just to prove it wasn't a fluke.
I might have blinked.
Yeah, it didn't take very long. Oh. Is it going? Or my camera can't?
No, you're not on camera.
No. beeping. Okay.
Who else, when they hear that sound, looks around and think, what on earth just connected?
Yeah. Yeah, except it's not connecting now, is it? So,
What's a dice goblin?
oh, the dice goblin. Oh, right. Oh, this is one of Shannon's. Oh, there it is. Sorry, it's that. Is that now working? No.
No.
It's not that. Dice Goblin is Shannon drew these things. It's to do with Dungeons and Dragons. So Dice Goblin is the thing that pinches all your dice.
All right.
Why they all disappear. Video, that's better. Right. No. No, looks like I've killed that camera. So I'll just show you it. Or try to. Yeah, put it one of them. Come on, everything's going horribly wrong. Video. It should be working. Can you see me?
No.
No. What can you see?
No. Dice Goblin.
I don't know. I can try and log out and log back in.
No, don't worry. It was so quick that I kind of didn't fully take it in. But
right. Okay. It's a mouse going one square forward, turning around and coming back.
All right.
Yeah. Which is one of the standard tests in the. It's an Arduino Nano, so it's got the same processor, but it's got very different hardware. All the LEDs are addressed via a latch, and the encoders are slightly different. It's the same encoders, but they're connected in a different way. They don't have the XOR, and they run on four different interrupts. But I think I only ended up changing about 5 of the 30 or so files that are in there, and probably 3 of those are very insignificant changes. So, that's pretty good. And it just worked. Yeah. I haven't done any tuning. I haven't done any, apart from setting the things in the config, to the size and the size of the wheels and those things. That's it. So
if you want to make a branch in Git with your stuff, and put a pull request into GitHub, I'm happy to have a kind of pick one variant branch running on there as well if you want.
Yeah, we can. Yeah, I can do that. I was wondering what you want to do with the, with the software, because we were talking about, what's needed to make the software more generic. And I think most of the issues we've had are things like turn the LED on, because you're using the hardware directly, effectively using fast write, and you can't do that on this because the LEDs aren't connected to the hardware. So you probably need some sort of function which is turn the LED on that can be rewritten rather than, So it's mostly that.
Absolutely. But I talked about the hardware abstraction. This sounds like a perfect case for starting to develop that. So any suggestions you have and any pull requests that you want to put into the repo, do that, and we can work through them and try them on variants until we've got something that's a bit more generic. That'd be great.
Okay. Yeah, that's good. I mean, basically the only difference really on this from your software is custom stuff that reads the encoders and custom stuff that does the sensors. In fact, all the motor stuff work fine with our drivers, which again are very different to the one on the Mars, but are obviously compatible. They just worked. So I was expecting to have to change that, but I didn't. So it's pretty good. It's just as it is. It wasn't difficult to get it to work.
Brilliant.
So that's good. Okay.
Thanks, Derek. Yeah. Anybody else?
I have on the question of that software. I had a bit of an epiphany last week about yet another variant on the maze solving thing. Just when you think it was all done and dusted, right? I've suddenly realised how to make that rather better. And time permitting, I will remind me if I get overwhelmed with other things. But I will try and go through that at Minos. But it's a significant improvement without taking up any more storage space, and it will let you tell exactly when you have an optimum route at almost no extra cost in terms of the algorithm. So,
okay.
A teaser.
Oh, yeah.
It's a bit late to
A
go through it
teaser.
all now.
Right, yeah. Okay. Well, if we want to steal your thunder from Minos. Anybody else while we're up?
Well, I'm trying to get my maze solver ready for Minos. It's using some earlier version of Pete's software and then various hacked on bits of mine. So it's not quite Pete's software, but it uses quite a few chunks of it. And that is now maze solving with in-place turns. And it goes to the center and back. It knows when it's found the optimal route. I've now got to write the code to do a fast run with in-place turns once it's found the optimal route. So I've still got a bit of coding to do on that, but it does find the center and get back, and can do that a couple of times.
Right. So we should have a few MarsBots running maze solving then.
Hopefully.
At Minos. Excellent. I'm a bit behind you because I've been saddling around getting power to pies and stuff like that, but I'm a dual gauge line follower, so I will be talking about that at Minos too. But I've made some mods to the line following board, so you can run it properly on a half size or a full size line and pick up the index and start finish markers properly. I've been doing that, but I have started. I'm just about, I think, finished tuning some turns on the Maze version of the Pete software. Not entirely successfully at the moment. Pretty good, but not entirely successfully. I've got something wrong with one of my turns somewhere. But looking good. Anyone else? Anybody else for anything? No? Okay. Well, if we're done, we're done. That's pretty much it. So look out for communication with Peter on the AGM and all the formal stuff for the society. And I'll be in touch probably by email again sometime after the 14th of June, just to try and finalise on where we all are with Minos and COVID precautions and all the rest of it. But other than that, thanks very much for calling in.
Okay. Thank you very much.
Thanks, Ian.
Okay.
Thanks.
See you. Take care.
Bye.
See you.
Bye.
Bye.
Thanks, everyone.